I needed it. I defend that website every year, and every
Oh,
year they're like, "You
absolutely.
need to make it up to date." I'm like, "Why? It works."
I laughed so hard when I saw it. This is exactly what I thought when I saw it too. Like, oh my God, it looks like every website I've ever made.
From the 1990s, I learned it all in
Yeah,
6 months in '94. Never got any better.
perfect. No, don't ever change it. I don't think
I
so.
don't plan on it. So, Jeff, were you able to get everything done that needed to get done for today?
Yep.
You had enough time. Okay, good,
Yeah.
very good, very good. I'm just checking in. Hey, because of the weird way this whole thing started, I wanted to make sure that everybody kind of, as we kind of learn how class goes, I wanted to make sure that everybody had enough time in this first week and give you more time if you need it. I know Olivia did. Hello, Olivia.
Hi.
Hey, your hair was curly last time, wasn't it?
Yeah, I curled it.
Well, okay. I just noticed it was different.
At least you noticed.
Looks fabulous either way.
Thanks.
So, Olivia, you did have time to get your stuff in. Susanna, hello. Nathan, hello.
Hello.
Hello. I'm just checking. I think I checked all y'all in already. Nathan, yeah, there's a few of your classmates I haven't heard from yet. I'm going to reach out to them individually. Did everybody on the call have enough time to get everything in for today before 8 o'clock? Or
Yes.
conversely, if anybody didn't, ask a better math question. If anybody didn't have enough time, just send me an email and we'll figure something out. Okay, we'll definitely give you that option for this first week. I know it's going to be a little bit weird because of the way Bobcat Web looks versus the web page, but good. I'm definitely happy that most of you had enough time to get that stuff in. And this first week's a little weird because this isn't new stuff. Like the stuff in those assessments was fractions. And the stuff for the assessment today is fractions and a little tiny bit of percentages. And then the stuff for Fridays that you're going to be looking at. And the stuff that you looked at for today, hopefully, isn't due till Friday, right? The R2D2 lab. I'm so bummed about that. That's one of my favorite labs to do in class with people because I actually bring these little game boards to class. And then we
I have one actually.
dude, it's the greatest. And then can you hear R2D2? It's fabulous. I mean, it makes a little noise and it's great. And it just makes class so happy. But here we are. Thanks, COVID. So anyway, hopefully you were able, if you got a chance to look at that before this meeting, hopefully you were able to kind of follow which video I wanted you to watch and figure out where your data was. So I guess, does anybody have any questions on it? This is your time. If anything didn't make sense, I'm going to fire it up right here so I can have it open too. Anybody want to chat about it? Anything unclear?
I have a question about the estimating chances homework.
Let's take a look at it then, Olivia. Let me pull it up here. Great. Scheduling, estimating chances homework. All right, let me pull it over here and share my screen, okay? All right. Share my screen. Here we go. Boop. All right, here we go. What are we looking at?
Question 7.
7. Do we need 1 through 6 to do 7?
Yeah, but this one was more just like I just didn't understand how you're saying it. And also you said pictures have to correlate with everything. And I didn't know where the picture correlate. It's kind of a 6 and 7 question. Like,
Okay. Let me just, if you don't mind, let me just take a quick scroll through this.
Okay.
So I want you to use this little website to flip pennies for you. All right, flip your coin 20 times, write down how many heads, repeat it again, write it again, once more. So you've done it, what, 4 times now? Once, twice, 3, 4. Yeah. So you've got 80 coin flips now, and you've written down how many heads in 80 coin flips. And then I did 20 more times, but I only showed you the first 10 right here.
Yep.
Okay. So in question 7, assuming this coin is, not rigged in any way, and the last 10, how many heads would you expect?
We'd expect half them, but
exactly.
The only thing that confused me is the last time we did this, you're like, the photos correlate with everything. I'm like, does the photo correlate with this? Are you wanting me to base my data off of the little photo you have above?
Oh God, no, Olivia. This question is saying without seeing the last 10, so how many heads would you expect? And then down here I show them to you. There's what actually happened right there.
That's what I thought originally. And then I saw the little photo. I'm like, last time I did this, he's like, the photos correlate, like with the dice one. Like,
They do. I'm saying here's the first 10 of that last 20.
I was just wondering if I was supposed to take my data from the little picture you had above it.
Oh, okay. I think what threw you for a loop. I think this makes sense. I think, Olivia, what threw you for a loop was I told you I flipped it 20 times, but then I intentionally hid the last 10 from you and I put them down here.
Yeah, I don't know.
So then I was asking you to predict if I did indeed flip them 20 times on those last 10. And you nailed it. I said, how many did you expect? And you said half.
Yeah.
Which is exactly what I would expect. I mean, why would you assume anything other than half? And it looks like it ended up being half, right? 1, 2, 3, 4. Yeah, it ended up being exactly half. Is that cool?
Yep, that works.
Good. And I love the question too, because part of this class is teaching you to process information that comes at you that might not be 100% super clear. So you need to ask clarifying questions. I just finished a video for y'all for week 4, actually, talking about that. Like, one of the most important things you need to kind of think about is when you're communicating math with someone, it doesn't necessarily matter if you're using exactly the right term, so long as both of you are communicating effectively.
Yeah.
And that's huge, right? So that's why I like asking other questions about, it might not be the same words we're using in the assessment, but you ask a question like that, we can ask something different and get things cleared up. So heck yeah, those are good questions. Hannah, you buying that? Okay. Thank you, Olivia. Fantastic question. What do we got, friends? Let's look at anything you want to look at. Hannah, go ahead.
I had a couple questions on the R2D2 lab.
Let's pull it up.
I just wanted to make sure I was heading in the right direction.
No, I got you. Let's take a look at it here. Let me share the screen again. How did the randomizer work? Emily and Yasher, how'd that randomizer work for you? Did it work okay?
Once I figured out that I needed to update the Flash player thing, everything worked fine.
Update the Flash player?
Yeah.
Jeff, what the hell is Flash?
Like, what's going on?
What the hell is this Flash she's talking about?
I
Flash.
just have to update mine too.
Oh my God.
Once I figured that out.
I'm going to put a disclaimer out real quick. I spent a large chunk of the summer switching all of my Excel stuff into Google Sheets, thinking that Google Sheets would be a more uniform, universal tool for you all to use spreadsheets with. I did not expect you to have to update Flash players. I apologize.
Well, that's okay. I probably needed to do it anyway.
Okay. All right, what are we looking at there, Hannah?
Okay, so for number 8.
8.
I wasn't entirely certain on what I was trying to say. So what I ended up putting down was just, it would be similar in that it is not a 50-50 chance, because there are 3 options for how R2 will land, makes it a 1 to 3 chance, or 3.3%. Does that make sense? Was that what you were looking for?
Oh, I like it a lot. Let's
Okay.
talk about it. Let's talk. I'm gonna put the pic. Actually, here, we're just gonna look at, since I have it here in front of me. There's R2. Can you see what he's doing right now?
He's on his side.
He's on his side. He's still on his side, isn't he, right there? I don't know if you can see that or not. He's still on his side.
Mm-hmm.
He's still on his side. Eventually, I'm gonna stop doing this now. Eventually, assuming that the game makes sense, what will happen eventually?
To
Land on his
a
feet.
different
He'll
way.
pop up on his feet. That's the whole point, is there's when you said there's 3 things that could happen, Hannah, I'd like to question that. I think there's 2 things that can happen. He either lands on his feet, or answer this as simply as possible. He either lands on his feet, or he
Lands on his side.
doesn't land on his feet. Somebody said land on his side. I like that answer too. That was fabulous.
Well, you guys had said that he could land on the dome, like leaning against the dome.
No, I said if he leans against the dome, throw that out and play again. That doesn't throw that. I didn't count that as a trial.
Okay.
I see what you're saying, because leaning against the dome, that's like a house rule that me and Max made up. And I'm going to thank you for bringing that up, that threw you for a loop, Hannah. I'm going to clear that up, the language in the lab. I appreciate your honesty telling me that.
Okay.
make a little note for myself so I fix that later.
That.
So there's really only two options, and that's kind of the way the game sets up. But even if I will, Hannah, even if he leans on the dome, that's not standing up, right?
True.
So you can make it what's called binomial. He either stands up or he doesn't.
Okay.
Is that fair?
Yeah, I think so.
But I want to focus on the first thing you said, which was fabulous. You said it's not 50-50. And that's exactly what. There are two outcomes. He either lands on his feet or he doesn't.
Mm-hmm.
But my hand looks huge in that camera. I'm sorry. Yeah. He either lands on his feet or he doesn't. But we can't assume it's 50-50. Why can't we assume it's 50-50?
More chances of him landing on his side than on his feet.
Oh, I heard somebody, but I couldn't see. Is that Susanna?
Yes.
Tell me that again, and then I want to hear from Olivia. Let me hear from Susanna first.
There are more chances of his landing on his side than on his feet.
It sure looks that way, doesn't it? Now, let me ask a question. Had you already watched the YouTube videos at this point? At this point in the lab, had you watched the data where I actually flipped them and you had to count, or was that after this part? I can look. Don't answer that question. I'll look for you. So we're doing number 8. No, it's after. You hadn't watched the videos yet. So at this point, you didn't know that what Susanna just said appears to be true. It does appear that he lands on his feet less often than he lands laying down. Yes? I mean, after watching the videos, that's what it seems like. But at this point, you didn't know that. It could have been this weird game where he lands on his feet constantly and never lands on his side, right? But the key, Hannah, that you said is you can't assume that it's 50-50. 50-50 means everything is likely in both cases. It's just as likely to get one case as the other. What's something in the world that's 50-50? Give me something in the world that's 50-50. Make up an event right now. What's 50-50 in your life?
Having a baby?
Having a baby.
Boy or
Boy or
girl?
girl having a baby. I like that. That's statistically, I believe, is 50-50. It's really close, right? Maybe it's like 51-49. Really close, though. Good. Give me another one. Be simple. Don't think extravagantly. Think simple. We probably talked about it in the lab, I think. Hang on. I got to go to my prop cabinet. Where the hell is it? Ah, here it is. I'll give you a hint.
Flipping a coin.
Flipping a coin. Heads or tails, right? Some of you are going to say, yeah, Sean, but it could end up on its edge. And you're right, it could. I've never seen it in 25 years of teaching, though. Flipping a coin. Sex of your newborn child. What else is 50-50? When do you, excuse me, puberty. When do you find yourself saying, it's 50-50? When do you find yourself saying that? Do you use that phrase from time to time? Do you use the phrase 50-50 from time to time? You do, exactly. But it's hard to think of when you use that phrase. And you use that phrase when you're trying to decide between two things and it really doesn't matter which one because each one is equally likely. I'm going to give you one now. I rode my bike to school today, just like I always do. I'm going to ride home, assuming I don't die between now and 6 o'clock tonight. Riding home, I might get a flat tire. It happens. I get flat tires during the school year. Actually, I get flat tires all the time on the bike. I shouldn't say all the time. I get flat tires. What is the chance of me getting a flat tire going home? It's 50-50 because I either do or I don't. Somebody critique that statement. If I say there's a 50-50 chance of me getting a flat tire riding home, what does that mean?
It means that you really can't predict the outcome.
Exactly. And I didn't get one on the way up here, right, Jeff? So should I maybe be expecting one on the way home?
Probably not.
And I didn't get one yesterday on the way up or the way down. And I didn't get one on Monday on the way up or the way down. And I didn't get one Sunday on the way up or the way down. Holy hell. Am I going to get a whole bunch of flat tires now to make up for the ones I didn't get? What do you think? Olivia's saying, no,
Probably
dude,
not.
that's not how
The
flat.
more times it's something like that, yeah, the more times it doesn't happen, the more likely it's going to happen in the future.
If it were 50-50.
If it were 50-50, sure.
But I'm going to tell you this. All last year, all the hundreds of commutes that I did to work and back, and all the hundreds of bike rides I did not to work and back, guess how many flat tires I got in the year 2019, 2020? Guess.
0?
I got more than 0, unfortunately.
Oh.
I got more than 0, but take a guess.
Is it 2 or 3?
1.
3. 3 flat tires in hundreds of rides. Does that sound 50-50 to anybody?
No.
That doesn't sound 50-50 anymore. But aren't there 2 outcomes? I either do or I don't.
Yes.
But it's not 50-50. And that's the big takeaway. Just because 2 things can happen doesn't mean they happen at the same rate. Is that fair, Hannah? You buying this?
Mm-hmm.
So how is this? This is all going back to your awesome question about Yasher and Emily, right? The question about Yasher and Emily wasn't about the fair coin. It was about the rigged coin, right? It was about the coin that was rigged, and I had to get you to figure out how it was rigged. How was the only way you could figure out that it was rigged? Were we able to get that question successfully? Let's take a look at that. Excuse me, puberty. My goodness, my voice is cracking all over the place today.
I gotta go.
Oh, okay. That's right, Olivia. You have to get to your next class, don't you?
Yep. Okay.
Did you get your questions answered? I hope you can always drop back in if you didn't.
I
Okie
did.
doke. Okay, good.
Yeah.
You got it, my friend. All right. Were we able to get number 7 with the rigged coin? Were we able to approximate the percent of the time Emily was taking the trash out once you changed the coin to rigged? Should we do it together?
Yes.
Okay, I like that. Let's pull it over. You want to
Okay.
make a copy? All right, let's do a little coding. Actually, not coding. Let's do a little spreadsheet work. All right, here, everybody see this okay?
Yes.
All right. One thing I don't know how to do in Google Sheets is actually zoom. Oh, here we go. Zoom. I want to zoom in a little bit. Make it a little bit easier to see for us. All right, is that better with a little bit larger? Can I change this to any number I want? Thank you, Google. Yeah, I'm learning Google Sheets too, my friends. Except it didn't work. Whatever. That's big enough, I think. All right, let's flip what the hell just happened? It just knocked it back down to 100. Oh, you pain in my butt. I'll just make it bigger via the air. Let's try this. All right, that's better. So what I'm doing is I'm flipping the coin right now. I don't know if you can see it. It's reloading as we go. So every time Emily turns up green, she takes the trash out, and then Yasher takes the trash out here. Why are we not seeing some here? This is very weird. Did yours look like this too, where there were blank cells?
Yes. I believe it is because there's no week 5 in the weeks of.
Oh, I mentioned that. That's right. Thank you. Thank you, Nathan. I actually mentioned that when I was making the spreadsheet because we have to have 52 weeks, and I had to spread out where the weeks were. You're right. You're right. Thank you. All right. So now let's change the coin to rigged unfair. This is unfair. Who likes this coin? Who likes this coin? If taking the trash out is awful, which of my 2 people likes this coin, folks?
Emily.
Emily likes this coin. Exactly. This coin is definitely slanted against Yasher, of course. So now the question is, how were you able? Was anybody able to figure out what percent of the time Emily's taken the trash out approximately? What did you put down?
1/10. 10%.
I hear 10%. Any other different answers? If you do it a couple times, I'm pretty sure I coded it to be 1/10. Now, sometimes, as you see, it's not exactly 1/10. Like there was a ways back, where it was like Emily took the trash out twice the entire year, which is way less than 1/10. But just like flipping a coin, oh, there it was right there. I flipped right through it. Emily only took the trash out twice there, but now she's taking it out. Sometimes she takes it out slightly more, like right there. And then sometimes she takes it out slightly less, like right there. But it looks like Emily's maybe taking it out about 10% of the time. So do you see how it's not 50-50?
Yes.
It's like 90-10. Well, how could it be 90-10? There's 2 outcomes. Either she takes it out or Yasher takes it out. That's the question, right, Hannah? You can have two outcomes that aren't equally likely. Friends, thank God life is not always 50-50. You'd get in a car crash every other time you got in the car. You'd break your leg every other time you skied down a mountain.
Oh, please no.
Right? Would you just say, Susanna, is that what happened to you already?
Yeah.
Oh, well, maybe it's 50-50 for you, but thank goodness it's not 50-50 for everything. If it was 50-50, Hannah, you see those lights that are behind you on your wall? If
They just,
the
like,
chance
burn
were
away.
always 50-50, that means half the time you plug those on, they would catch fire. Thank goodness they don't, right? What's the chance of those lights catching fire in your room? I don't want to think about it. Is that what you're saying? I don't want to think about it. It's probably very, very, very close to what?
0.
You just said that. Thank you. Somebody just said that. I don't know who it was. Thank you, whoever just said that. It's probably very, very close to 0. Even those two outcomes. Either they catch fire or they don't. Make sense, Hannah? Your question about number 8 was so good. And number 8 is probably the hardest question in the entire lab, honestly, because it asks you to make the connection between Emily and Yasha's rigged coin and R2-D2. You know how you said earlier we can't assume R2 is 50-50. 100% correct. I agree with you. Can't assume it's 50-50. But there are still what? Two outcomes. So just like Emily and Yasher, there are two outcomes. Either R2 lands up or he doesn't. Either Emily takes the trash out or she doesn't. But just like Emily and Yasher, we don't know the rate at which something is happening. This is a huge branch of statistics. You've probably heard this over the past month as people argue about coronavirus. What's the infection rate of coronavirus? Nobody knows. But you either get it or you don't. Right? You either get it or you don't. Now, that's a little bit simplistic. There probably are gradations of the disease you can get. But this is what statisticians study all the time. They look at a result of a bunch of experiments. Throw a whole bunch of coins, see what happens. Slap a whole bunch of domes, see what happens. Deal a whole bunch of cards. Study a whole bunch of teenagers. Collect the data, and then look for the presence or absence of some variable. Hannah, that was a long answer, but was it a good answer?
Yes.
Okay, good. Everyone else, I hope I didn't just confuse the hell out of you, but I really wanted to, Hannah, I'm so glad you asked for that question because it does. It's a deep dive, right? It's a deep dive into a phrase that we use all the time, 50-50. We constantly say 50-50 without even thinking about it. And sometimes we don't mean it. Sometimes we mean, yeah, there's two outcomes. But that's very different than 50-50. Cool. Thank you, friend. I didn't mean to freak you out about your lights behind you. They're beautiful, by the way.
They're LED. They should be fine.
They should be fine. I've got some in my office too. I got a bunch of Yodas hanging around my office thing there. So, and they're LEDs as well. Little Yodas. Learn math, you will. So hopefully they'll be fine as well. Little bit of a Star Wars fan. So, okay, my awesome friends, let's hear some more. That was fabulous, Hannah. Thank you so much. Anything else bug you? Sorry about the flash update you had to do for Google Sheets. I'm still learning Google Sheets as I go myself. Oh, Marley, hi. Let me check the rest of you in. I think I got most of you last time, but I'm just going to double check to make sure. Marley. Yep, you're right there. And Alicia, hello, Alicia. We got you. Hi.
Hello.
Hello. Matthew, I got you earlier. And Nathan, I think I got you earlier. Yeah. Yep. And Abe got you. And
Yes.
Susanna, what's your last name again? Man,
Hernandez.
wow, puberty is striking hard today. I apologize. My voice is cracking all over the place. What was it, Susanna?
Hernandez.
Hernandez. This is weird. Why do I not see you? Hang on. Hernandez. With an H, yeah?
Yes.
Oh, Susanna. You're sitting in Math 98. You should be in Math 105. We will see you at 1 p.m. for 105. Is that okay?
Yeah. that's
Okay. We'll catch you then, okay?
Okay.
All right, my friend. Remote learning. Isn't it a joy? Now, hit me, awesome people. What do you got? What do you want to talk about? Anything else in those assignments you want to chat about? R2-D2. After you looked at a bunch of data, does it look 50-50 for R2? Does it look like he pops up on his feet at the same rate he lays down on his side?
No.
Nah, it does not, does it? It looks like he pops up on his feet less than he lays down on his side, which I think, who said that earlier? Somebody actually said he lays down. Was it you, Alicia? Somebody said he lays down more often than he lands up. And I don't know who said that.
I think it was Hannah.
It was Hannah. Okay. Yes, that's true. Yeah, after you look at the data, it cements that fact. I'm going to give you one little thing. I don't know how many of you are going to go past Math 105 in your majors. I'm not sure what your majors are. We have any psychologists here? Psychology majors? Oh, yeah, definitely, Hannah. You will go to Math 243 and 244. Not trying to scare you off. Just trying to get you pumped up because those classes are badass. Those are the kind of classes where you actually estimate the probabilities with margins of error for things like R2-D2. Totally rad. Totally rad. But the idea is that what statisticians do is they come at an experiment like this. Suppose this was a meaningful psychological experiment. We're going to estimate the probability that R2 lands on his feet. They start by assuming it's 50-50 and then see if the data deviates meaningfully from 50-50. Because if you don't know any better, assume it's 50-50 and then show that it deviates. And that's what kind of the foundation of statistical, what's called inference is. Start in the middle and then see where the data takes you. See where it goes, left or right. Cool. Y'all okay? You still waking up? All right.
Mhm.
All right. Okay, good, good. I'm just trying to read some faces. Alicia, what do you got? You got a question coming?
Yeah, a
Oh,
lot.
let's hear it.
Can we kind of go over the fraction parts on
Of
the
course we
labs?
can. Of course we
Okay.
can. Is that, let me minimize this. Is that, what's that, down? Past number 7, is it the part down here? Down here?
Yes.
Okay,
Yes.
good. So if I may ask, I don't know what video you got, Alicia, but how many times did R2 land on his feet in your video?
Oh, I haven't even watched the video.
Oh, that's going to be confusing as hell then. Maybe we should
Okay.
watch one real quick. Maybe we should watch one real quick. Hang on. Okay, so Alicia, let's do the little code. If your first name starts with A through E, okay, so you're a 1. If your last name starts with A through M, you're also a 1. So you're a 1-1 so far. Month of your birthday. What's the month of your birthday, Alicia?
May.
May. So you're 112. So the video you would watch is actually right here, 112.
Okay.
So what I want you to do right now. Can you
Okay.
can you watch this video right now?
No,
You can't? All right, here we go.
not right now.
Here we
Okay.
go. Let's count. There's 1. He's on his feet once so far. Just once. 2.
2.
4.
Statistics. Isn't it enthralling? Ha ha! I counted 4.
Yeah.
Okay, that's the number you need, Alicia, to do the next questions. So now we know, for you anyway, what number 9 is, right?
Okay.
He landed on his feet 4 times.
4 times.
Fraction would be represented by that. Did you catch how many times I pushed the dome?
Oh gosh, no.
That's okay. I think I tell you up here.
20 times. Okay.
Yes! So what's the fraction, my awesome friend?
5.
Oh, no. Fraction.
Or what?
How many times on his feet out of how many trials? So how many times did he land on his feet?
So 4.
Out of,
20.
there's your fraction, right?
Okay.
4 divided by 20. There's your fraction. What you did was you did 20 divided by 4,
I did. Okay.
which would be, what would that be? Actually, that's a fun thought. 20 over 4. I think I know what that would. That's not what I'm asking for, but what would that actually be? It would be
We were
5.
five,
It would be
right?
5, but what would that number represent? Anybody want to take? I didn't ask this question in the lab, but it's a fun question statistically to think about. What would 5 represent? Anybody have an idea?
How many times it landed on its side?
Wouldn't that be 4? Well, actually, time out.
Yeah.
He landed on his side 16 times, didn't he? If he landed on his feet 4 times,
Okay.
that means he landed 16 times. Maybe I should pull this question back. But Hannah, you want to say something? Hannah Flaherty, do you have it? What I was getting at was roughly every 5 taps, he lands on his feet once. That's where I think your 5 comes in, because we did it 20 times, right? 4 out of 20, which if you write it as a fraction, reduce it, it's 1 out of 5, right? 1/5. So roughly 1/5 of the time he landed on his feet in your 20, which means that every 5 times we every 5 times we pop the dome, he lands up on his feet
He
once.
lands on it once.
Yeah, but I was asking for
Okay.
the other way, 4 out of 20, not 20 out of 4. Is that fair? You got 11 weeks of this, Alicia. I hope you're up for it.
Okay. Oh, yeah. Okay.
So now I think from there, the rest of it should make sense, I think. All you got to do now is change the denominators. So the next one is denominator of 40. So if it's 4 out of 20, that's what the fraction we have, yeah?
Okay.
What number would be here if I wanted to have the same value but be out of 40?
8.
I agree.
8.
I agree. How'd you get that?
I just doubled it.
Oh, hell yeah. As long as you do times 2 to both, this fraction maintains its value.
Okay.
Good. One of the reasons I like these kind of questions in here is we're going to build on this starting next week with dimensional analysis. Good stuff.
Okay.
Good stuff. Good stuff.
Yep.
All right. What's the next
All
one?
right.
I forget the next one is. Hang on. Percentage. Yeah. What's the percentage? What does percent mean?
Per every
Oh,
100.
you divide
Nathan, say it again a little bit louder.
Per every 100 sin.
Yes.
per every 100.
Per every 100. Yes. A percent is just a fraction. It's got a weird name, and we use it too much all the time. I'm going to bring up a story that just happened. I got a message on Instagram today from a former student. I'm going to run a percentage question by you. But if we want it to be out of 100, then what would it be out of 100? Let's get this out of the way. That might get in the way.
It'd be 20.
out of 100.
I hear 20 out of 100 is what I'm hearing. Because how do you get from 20 to 100? Times 5, yeah? Or
Yeah.
yeah, 20%. So in your video, Alicia, R2
Okay.
landed on his feet 20% of the time. Now, that's a little misleading because when you hear the word 20%, as Nathan correctly said, that literally means 20 per 100. Did I flip the dome 100 times?
No.
I didn't. Very good. Whoever just said no very quickly, thank you for that. I did not. I did it 20 times. So you got to be careful when you see percentages in the world. Always make sure you know which number the percentage is being taken of. I've seen this happen around COCC quite a bit, and it's appalling. I've heard things like, well, let me do, what's 14 times 4? 56. 56% of all the students in the journalism class this term didn't pass. 56% did not pass. What they don't tell you is there were only 7 students in that class, and 4 of them didn't pass. 4 out of 7 is 56%. But there's only 7 people. So saying percent is a little bit unfair in that situation. So that's why you want to be, Gabrielle, I hear you, and I see Alicia, you're nodding. Very good. I want you to, no, keep nodding. I think this is fabulous. You pay attention to that. Because percentages get chucked around like they're always meaningful. And my goodness, sometimes they're not. Sometimes they're not. I just wanted you to do that to make sure you know how to do the math. But I would never report that. Go ahead, Alicia. You have a question, comment, concern.
I think I'm gonna run it through, read it, watch the videos. Yep, have
And
questions.
I'll be here till 10 if you want to drop back in, okay?
Perfect.
You rock.
Okay,
Great
thank you.
questions. I want to thank you for those.
Okay. Thank
So
you.
I have
Bye.
a kind of logistical question. So my Excel won't change when I click those buttons.
So your sheets, when you open sheets,
Mm-hmm.
it won't. So can you actually, Gabrielle, could you actually share your screen with me?
Mm-hmm.
Let's see if we can troubleshoot it.
So I had the same problem with my Google Sheets, but I found a workaround as
You
well.
did.
Yeah, I kept unchecking and checking the coin fair type or type.
Oh God. So in other words, yours wouldn't randomize, Nathan.
Yeah, that's what I was doing, but then I realized that after doing it a few times, it goes back to kind of the same.
Okay. So
I'm
do
not
me
sure
a
if it's
favor,
working.
Gabriella. Do me a favor. So unclick that box. Okay. So that does work. Do me a favor right now. Click somewhere else in the sheet. Okay. Now try to click that box and uncheck it a couple times. Let's just see what happens. Okay. So that's behaving kind of. It's not really doing. I mean, Nathan, this is your solution, right? Click the box and unclick the box.
Yes.
Do you have an F5 button on your keyboard, Gabriella?
Mm-hmm.
You do. Is it all by itself or is it attached to something else? Are there other things on the button too?
Yeah, it has a volume thing on it.
Okay. Do you have is it a Chromebook or something like that?
It's a keyboard.
It's working.
Oh,
It's working.
hold on.
It just did it. It's doing it. It's a little bit slow, but it's working. You got it.
Okay.
It's like taking your car to the mechanic, Gabriella. It doesn't behave, and then you go to the mechanic, and it works just fine.
Do I do the F5 when it's checked or not checked?
Well, both. The first one, I'm telling you the coin is fair. And the
Okay.
idea is estimate the percent of the time that Emily has taken the trash out. So it
Okay.
looks like if you look at if you had to guess right now, Gab, look at that. How many of the names, Emily and Yasher, there's 52 names up there. Roughly how many of them in fraction are Emily, are green right now? Roughly.
Out of 52?
Yeah, just give me a fraction. About how many of them as a fraction? About
30?
Okay, so make a simpler fraction.
Okay. Third?
A
Of
third?
the-
I think
yeah.
there's more than, click it again. I think it's more than a third, don't you? Do that F5 again like you did. Yeah, let it do it. Let's actually count. Gab, let's count. 1, 2, let's go left to right, up to down. Is that okay? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I got 29.
Okay.
So 29 out of 52 is about what?
About half.
And that's what I was looking for, because Emily's taken out the trash about half the time because the coin is
Fair.
fair. They're flipping a penny, so to speak, right? They're flipping a penny. That's what I was asking you to approximate. And then when you uncheck the coin, when you uncheck it and it becomes an unfair coin, what percent of the time is Emily taking the trash out? Now, you can't just look good. Thank you. You're doing exactly what I need you to do, which is click F5 a few times and kind of keep a running track. And I gave you a hint. I said use a denominator of 10 as the fraction. So it seems like roughly, approximately, how many times out of 10? You may have to click it a few more times. This is a low one right here. You may click it a few more times. There's that. And the hint, roughly how many out of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 out of 52, which is about what?
4 out of 10?
It's not that high. 4 out of 10 would be 40% of the cells would be green. It's about
One out of 10.
Exactly, girl. It's about 1 out of 10. So if you would unshare your screen real quick, Gab, what Emily and Yasher are actually using is a 10-sided die. Not a fair coin. They're using a 10-sided die. Now, just like in the stuff you turned in today, you can make a 10-sided die a coin, can't you?
Mm-hmm.
Yeah, oh yeah, we can make a 10-sided die a coin. Just make all the even numbers heads and all the odd numbers tails, or something like that. Or make all the numbers on that side heads and all the numbers on that side tails. But what Emily and Yasha are doing is, and I think Emily rigged this in her favor, good for her, is she said, if this thing comes up 1, I'll take the trash out. If it doesn't, you take the trash out, Yasha. And that's 2 outcomes, right? Either comes up 1 or it doesn't. But the problem is there's a lot more ways for it not to come up than to come up. Gabrielle, does that make sense?
Yeah.
What a fantastic question. I can't thank you enough for that one. Boom! Well done, people. I love these questions. Yeah, yeah. This lab is so much fun to do with you in person. I'm not going to lie to you. We don't have the Google Sheet thing because you're all doing the lab with the R2-D2s. So I thank you for your patience as we make this a remote lab. Me and Jessica spent about a month crunching this thing out over the summer, writing the Google Sheets, recording those videos. That's me at my dining room table. Pop, pop, pop. At one point, did anybody get the one with the cat in it? At one point, one of my cats jumped up on the table. I'm like, get the hell out of here, Willow. So, anyway, remote teaching. Woo! What do we got, friends? Other questions?
Can I ask about 16 and 18?
Of course you may.
Of
course you
because
may.
I was not quite sure about those because you did that little video about the outliers for 16, and I will admit I didn't understand that at all.
That's Anna. I love the honesty. I appreciate you telling me that.
I mean, I tried, but
it's okay. The video was recorded in my shed with a bunch of pennies. You make do with what you got laying around. Okay, so I asked you to look at these 2 dot plots. Let's back up real quick. Do the dot plots make sense? Do you know what you're looking at when you look at these?
yeah, more or less. And I understood the outliers and the curve, but
Sure.
I was trying to figure out what to say that and I got to the point where well, there aren't as many outliers in Max's model.
I like that. Okay.
I wasn't sure where to extrapolate further.
No, Hannah, first of all, I want to take what you just said and feed off of that with your permission.
Mm-hmm.
So just so everybody knows, hello, Amanda. Just so everybody knows, hello. What Hannah is referring to are these kind of extreme values down here. This is when in class, this is the normal method, and this is Max's bounce method. So the normal method means you click the thing and then you pop it back up and let it, and Max's bounce method means this is Max. Kind of. I mean, it's on the table. And the normal method is, so the real thing oh, sorry. I was sharing my screen when I did that. Let me unshare my screen and show you that again. The normal method is you have to push, wait for the click, and then release. Max's bounce method is, and he was convinced his way was better. The reason, now some of you might be thinking, Sean, what the hell? Why are we playing with an R2-D2 board game? Well, to that, I want to get to your question, Hannah, because it's fabulous. To that, I want to ask you, does anybody take Advil when they have a headache?
Tylenol.
Or Tylenol? Or some kind of analgesic or something for a headache? Some kind of Advil, acetaminophen, acetaminophen. Why do you take those medicines for your headaches or your pains?
It's going to make it go away.
Be good, Amanda. Well said. I'm going to put my mask on to be in solidarity with you. Yes. Yes. Because it makes the pain go away. Actually, you're doing this right now. It makes the pain go away. Because at some point, the Food and Drug Administration did a series of studies where they compared the effects of having versus not having the 2 medicines. Having the medicine versus, the medicine. Having versus not having Advil. Having versus not having Tylenol, so forth. We're doing the same thing here, Hannah. We're trying to see if there's a difference between. And this is intentionally not a simple question. So I want to track down what you said. So what Hannah focused on was, okay, so here's the normal way and here's Max's bounce method. Hannah noticed that there were an awful lot of, she called outliers in the normal method. This is people in my class who played the game, and if they popped it 20 times, ended up with 8 standing R2s or 10 standing R2s or 11 standing R2s. They're kind of separate from the rest of the graph over here, yeah? Like there's a big chunk of data over here and then this weird little separation over here. If you look at Max's bounce method over here, for whatever reason, all the data is kind of clumped together. There's no real separation. There's no gap and weird little extremes. I like it. Where did you go with that, Hannah, after you did that?
That was about as far as I got because I wasn't entirely certain. I mean, they're really kind of very similar and they have the same shape to them.
They do. As a matter of fact, if I may,
that was the answer.
If I may, here, let's overlay. So it sounds like you watched the videos and you understood the whole curve part I was talking about.
Yeah, more or less.
So oh wow, that's a weird little thing at the beginning there. Let's draw a little curve, shall we?
Mm-hmm.
Here's kind of the curve on the normal way. If you were to fit like a smooth curve on top. And here's kind of the curve on Max's bounce method. Now, do you remember, Hannah, in the video you watched, when I talked about the high... Say that again! Whoever's going to jump in, jump in. Somebody was just jumping in. Was that in my head?
Sound like they were yelling at someone.
Oh, they were yelling at someone. Damn, I hope they were yelling at me. Damn, that's okay, though. Y'all yell at me all you want. Do you remember, Hannah, in the video you watched, when I mentioned the humps on the curve?
Yeah.
That's okay.
Sort of.
Be honest in here. If you don't remember, you can be like, I don't. And that's totally fine.
Yeah, I just don't remember specifically.
That's okay. That's okay. Does anybody want to chime in? What do you think the hump on the curve indicates in this? What does the hump mean? The highest point on the curve. What is implied by that? Look at the dots. What's true about the stack of dots under the hump?
The number of times R2-D2 landed on his feet.
Right, exactly. Was that you, Nathan?
Yes.
I can only see 5 of you right now, but I can hear, I think I know your voice now. It's the number of times R2-D2 landed on his feet, but so is this. This is 8. This is 10. This is 11, right? What's going on under the humps? What's up with these 2s and 3s? Why is the hump by the 2 and 3? Because 2 and 3 is the result that happened the
most.
Say it again.
Most.
Say it again.
Most.
It's the result. Thank you for your patience. And I can't see your face, so I don't know if you're getting pissed at me yelling at you. I apologize if you are. It's the result that happened the most. So when you see a graph like that, those of you in psych, I got some psych majors. Yes, I saw Hannah, you're a psych major. There might be a couple other psych majors in here too. Sociology majors, psych majors, statistics, when you take your stats classes, when you see those curves and those humps indicate the results that happen the most frequently. That's, Hannah, if I may bring in your awesome mention of outliers. It's the opposite of an outlier, right? An outlier is something that doesn't happen very often. The hump shows you where things do happen the most often. Fair?
Yeah.
Okay, back to the graph. So if I look at where the hump is on the normal way, whoops, why is it not drawn? There it goes. The hump appears to be around 2 and 3, yeah?
Mm-hmm.
But if I look at where the hump is on Max's bounce curve, it looks like it might even go as high as 4, maybe even just 3 and 4. So do you see how that's one argument in favor of Max's bounces?
Okay, yeah.
Even though the outliers show that you can do better in the normal way, the traditional looking at the typical outcomes, look like it might be a little bit better to do the bounce method on average. Does that, Hannah, you buying that?
Yeah, I think so.
Good.
Is that the kind of the answer that you're looking for to 16?
So just so you know, 16 is one of those questions where I'm not looking for a specific answer. I'm asking you to process some data and come to a conclusion.
Okay.
You're in the world of probability and statistics in this class very often. There isn't going to be a 100% correct answer. It's what is the data showing you? It showed you two different things.
Mhm.
First of all, it showed you that the normal method has outliers, which might imply that there's a potential for better performance using the normal method. Maybe we should do more trials and see if those are really outliers or if they will eventually connect back to the rest of the curve. But Max's bounce method shows that the curve looks like it shifted a little bit. Maybe the bounce method is better because the hump is a little bit to the right.
Okay.
So I know this is infuriating for some of you. You're like, just tell me x equals 3. You can't. That isn't how statistics works. It works by analyzing the data and looking at what the patterns in the data tell you. Hannah, fair?
Yes.
Good. So there is not a correct answer. Is it a correct or n correct answer? There's not a correct answer I'm looking for here. I'm looking for you to think about what the graph is showing you. And hopefully our little discussion right then helped a little bit. Let's look at it again. These little humps where I overdrew on top of the data. All I did was I smoothed the data with a curve. The hump of this curve appears to be a little bit further right than the hump of this curve. Is it a lot further right? Don't answer that question. Don't answer that question. Is it a lot further right? Good. You didn't answer that question. Because we're not here to do that specific of a measurement right now. We're not the FDA testing Advil. We're not the FDA testing the coronavirus vaccine. We're just looking at these two curves saying, ooh, maybe there's a little difference here. Maybe the bounce method's a little better because that hump's a little bit to the right. Hannah?
Okay.
That okay? Anybody else jump in if you don't like that? Or give me a thumbs up if you're okay with that. There, okay, good. I see lots of, Jeff gave me 2. Hell yeah. That means if somebody else gave 0, on average, you both gave me 1. Boom, that's good math. Check it. It's terrible. Sorry.
I have another question that might be another method to the R2D2.
Oh, let's hear it, Nathan.
Have you ever tried without the second die in the dome?
No, I've thought about that because I didn't want to take it apart and then not be able to put it back together. That's such a great question, dude. Yeah, so Nathan's question is so good. What if you took the die out? And I'm afraid for 2 reasons. First of all, for example, last night, my wife picked up my Telecaster guitar and the input jack ripped the entire guts of the middle out. And I'm having a hell of a time putting it back together. Sometimes I just can't put things back together well. And I'm nervous about putting this back together in one piece. And then I thought, well, what the hell? I'll just buy another one. But they discontinued this game. So literally, I've got 6 copies of it, and I don't want to risk. I like this lab a hell of a lot. I don't want to risk not having enough copies of this.
Fair.
So I've thought about that, though, dude, right? Because if you think about it, that would be a good follow-up lab, wouldn't it?
Yeah.
Is there a difference with how often R2 pops up with the die or without the die? That's a fantastic question. I just don't want to risk ripping my my boards apart to get to it. You know what, though? That could be a fun one. Excuse me, puberty. That could be a fun one with just normal trouble. If anybody's ever played the game of Trouble normally, it's got 2 dice inside. You could actually check to see if the dice impact each other by bouncing off of each other. My gut feeling is they wouldn't, but these are all statistical questions. Nathan, you just posed what I would call a Math 244 inferential statistical question. And if we were in 244 together, I'd probably see if I could go on Etsy or eBay and get a few more of these, not Etsy, but eBay and get a few more of these, rip them apart and try to put it back together and test it. But we're not. Love the question, though. It's fantastic. Thank you, sir.
Well, I have an actual question to the lab now.
Well, let's hear that, too.
Yeah. We're going to go to number 4 on the lab.
Yeah, we are. hang on. Let me scroll. Is this that's a screenshot? We can just go this. Number 4. Right, here we go. Take a look at the results in the screenshot of the first page of this lab. Okay, let me look at that again. Okay, here's the screenshot. Yeah, okay, here we go. Considering your answers to the previous questions, does it bother you at all that Emily had to take the weekly trash out every single week in June? So real quick, Nathan, before we answer this, I want to make sure. Oh, okay. So numbers 1, 2, and 3 are all involving the fair coin, yeah?
Yes.
Okay, I'm ready to hear your question about number 4. So are you bugged by this?
So personally, no, I'm not. I'm not bugged by it, but I guess it ties back to what Hannah was talking about with the outliers. Does it somehow apply to the same way, like that there's an outlier in the randomness or the 50-50 chance?
Yes, and actually, what it is actually 2 other things as well. Hey, Seth, is that a Yeti Blue? Those microphones are fantastic. Oh yeah, those things are fabulous. But well done, well done. So Nathan, it applies to the idea of outliers, absolutely. But it also applies to a couple other things. You ever heard of something called the gambler's fallacy?
Negative.
Has anybody ever heard of the gambler's fallacy? If you ever spend any time in a casino, you'll see it. Somebody, I'll tell you a story. Perfect example of a gambler's fallacy story. I went to see one of my favorite bands from the 80s. They're called Tesla. They're still playing shows, thank God. They played at Chinook Winds out in Lincoln City about 3-4 years ago. And there's an auditorium there in the back of the casino. You have to walk through the casino to get to the auditorium. Brilliant, brilliant marketing on that thing. So I'm walking through the casino, and I see there's this crowd around a slot machine. So there's a row of slot machines, and there's this like crowd of 30 people around the slot machine. So I'm like, what the hell is that? So I decide to peek in. I look in, and there's this little tiny old lady sitting on the stool, feeding coins into the slot machine and pulling the arm. And I watched her a few rounds, and she kept losing. Like, she'd pull the arm and she lost. She'd pull the arm and she lost. And the crowd, every time she lost, they went, yes. So she'd put a coin in, pull the arm, she lost. The crowd was like, yes. And I watched it for about, 20, 30 seconds after she played about 5 or 6 rounds. And I tapped the guy on the shoulder. I'm like, dude, what are you doing? And he's like, we're watching her lose. And I'm like, oh, we're whispering now. Okay, we're going to whisper. Why are you watching her lose? And then he said, because eventually, if she keeps losing, she's going to get tired of losing and she's going to stand up and leave. And then we're going to try to jump in because she's been losing so much. She's going to have to win soon. That's the gambler's fallacy. Assuming that somehow that machine is remembering that this little old lady is losing and that she's due to win next. So the same idea, Nathan, could be applied here. Let's suppose Emily in June takes the trash out in week 1. And she knows, and Yasher knows, that they're flipping a coin to decide the next week, right?
Mm-hmm.
So she might erroneously believe that because she flipped the coin heads here, it's going to be tails next time. But it wasn't. It was heads again, wasn't it? And then she might say, oh, I flipped coins heads both times. It's got to be tails next time. But then it wasn't. And then she's like, holy hell, now it's June 21st. It's got to be tails next. But then it wasn't. So the problem is, if you are surprised by Emily getting 4 trash goes in a row, it's only because you're hyper-focusing on just those 4 outcomes and not the entire year. Look at the entire year. When you look at the entire year, how many times did Emily take the trash out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. She's a little bit over 50-50, but not at all, I would say, an extreme amount over 50-50, right?
Yeah.
So like, for example, in November, Yasher took the trash out more. In September, Yasher took the trash out more. So the idea, I think, is definitely tied to what Hannah said about outliers. We're focused too much. And I did this, and I put that in at number 4 intentionally, because the problem is the news media will jump on this kind of stuff. They'll jump on this kind of stuff. They'll say, look at this section right here. Look at what's happening in this section right here, and ignoring what's happening all around it.
Big
But only
picture.
focusing on this one little section. Where if you actually have an entire group that you should be looking at to pull a rate from, the rate is nowhere near as extreme as one little tiny section would be. Nathan, does that kind of make sense?
Absolutely makes sense.
Awesome. I love that question. Thank you, sir. Give me some more. What do you got, people? I love these. Every question you've asked today is exactly the kind of question I would want in this room. And I'm also recording this. So if anybody wants to come back and watch it later, I'll have the video in the Blackboard section for Zoom recordings. But every question you've asked, Hannah's question, and where did I lost Alicia? She must have had to go out. That's totally fine. Every question, Nathan's question that have been coming in are fabulous. So Gabriella, yours was great too. What do we got? What do we got? Hello. I set my little doorbell to ding. Hey, Angie. Are those old school wooden skis behind you?
Yeah.
Nice. Are they telly skis? Old telly skis?
They are, yeah.
Dude, I have like
Really
almost
old.
the same pair on our wall at home. I love this.
That's awesome.
That is so great. I was walking by, I used to live in Delaware, and I was going out for one of my daily runs, and some dude had thrown those in his trash and an old iron push mower from like 1910. I'm like, dude, do you have any idea? Not to the store.
No
I'm like,
way.
you're throwing away history. He's like, you can have it. Okay.
Score.
So great. So great.
That's awesome.
You ever try to ski on them?
No, no. My
Don't.
husband probably has, but no.
Don't. I tried on ours and I almost broke my leg. Good morning.
No, I wouldn't do that.
Plus, you're smarter than I am.
I don't know. This R2D2 homework is making me feel like maybe not.
No, it's making you, what it's making you do, Angie, if I may be so bold, is it's pushing you into the realm of discovery versus just kind of rote mathematics. So let me hear any question you've got.
Okay, right.
Let me hear any question you've got right now.
Okay, well, mostly what I'm struggling with is so many unknowns. So I guess I just need to be comfortable with not knowing.
Well, you know what? With your permission, Angie, I'd like to include that quote on my website. Is that okay? Without putting your name on it. Without putting your name on it. I don't know if you saw my website is full of student quotes.
I did. I like them.
I think you just, yeah, and I would like to add you to that with your permission. I'd like to put that on the website without your name.
Perfect.
But I think what you just said was absolutely beautiful. And I'm going to see if I paraphrase you correctly here. You said, there are so many unknowns, and I just need to get comfortable with those unknowns. Is that right?
Yeah.
Okay. Well, and that's exactly correct. That's exactly what you have to do. And part of my job, I would say my most important job is twofold. First of all, help you get comfortable with those unknowns. But secondly, give you the little bit of mathematics that we need to build up your comfort level with those unknowns.
Okay.
So let's focus, before we work on the unknowns, let's work on the knowns. What math in this lab that you saw were you like, I've seen that before? What's something that popped up when you're like, I've seen that math before?
Well, like fractions and averaging?
Exactly. Fraction. Oh, averaging. Very good. You're ahead of the curve if you have already seen averaging before. Well done.
Ooh.
Fractions, averaging. You've also got some percentages, a little bit of percentages in there too. These are things you've seen before, right? Seth's nodding along as well. Absolutely. This is the stuff we've seen before. That's why I started this week with this, because I know the math wasn't going to be new for you. What's going to be new is what I'm pushing you to do with the math. So give me the first unknown that kind of threw you for a loop, Ange.
Well, when I was doing the random coin flipping, I was noticing that, you know, I didn't just do it a few times, I did it numerous times. And I couldn't see much of a pattern that was making sense to me.
I'll tell you what, let's do this together. And I think this will behoove everyone if we look at this together. I'm going to open this sheet up. I don't think I already did. Oh, I did actually. I'll make another copy. We're going to do this together. Okay, Ange?
Okay.
We're going to generate some data as a class all together here. So I think this is big enough for us all to see. Can you see that okay?
Mm-hmm.
Okay, so what I'm going to do is I'm going to keep track of some data over here. Not there actually, because that's where the actual spreadsheet. I'm going to insert some columns that we can write in. Okay, these are blank columns. So I'm going to put Emily's, and totals. And I'm going to make that so we can actually see it because it's in the wrong color font right now. Font color black so we can see it. There we go. Now, how many total weeks are we seeing up here?
52.
52. So I'm going to put the number 52 in black font all the way down. Okay. So let's look at 52 and let's copy it down a few. So let's do it a few times. And what we're going to do is we're going to count how many Emilys we see in each of these times that we reloaded. Poor Emily, this year sucks for her, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. You know what? I'm going to try something. If that's okay with everybody. I'm going to try a command. If you ever used Excel or Sheets before, let's see if this works. Let's see if I can make Sheets do this for me. Ah, it's working. So right now there are 28 Emilys in that group. Cool?
Mm-hmm.
Now there are 26. Now there are 25. If anybody's interested in that command I just typed, I'd be happy to make a quick little YouTube video and send it to you. You just send me an email and I'll send it, okay?
Yeah.
Now, obviously, Angie, we can just count them, right?
Mm-hmm.
But this is a little bit quicker, isn't it?
Yes, it's amazing.
I think so, yes. 29, 32, 21. Oh, she got it. That was a good year for her. I wish I had finished counting that first year now to balance out the good year. 24, 30, 26. Want to keep going, or do you think that's enough?
That's enough.
That's enough. Okay, let's make this font up here darker. So my question to you in this first bit was, do you see, actually, let me see what the actual question was. I forget what my exact question was, Angela. I got to go back and look.
Okay.
I want to look. Generally, about what fraction of the time does Emily take out the trash? Okay, let's make a fraction out of it. So let's add up all these. Here's a fun little trick that I'm going to teach you eventually in this class about Sheets. But if you actually grab all of this, I highlighted all that data. Can you all see down here at the bottom where it says sum 241?
Mm-hmm.
You see that? That's pretty slick. It actually, if you highlight a bunch of data, it'll tell you what those data add up to. So if I highlight all that data, it tells me that there are 241. We have seen 241 Emilys throughout our little experimentation. So 241 Emilys. How many total weeks did we see in our experiment? Well, it looks like 468. Yeah. What fraction is that? I don't know. What does that come out to be? Let's divide them. Oh, what's that really close to?
50%.
Say that again.
50%.
One more time for the people in the back set.
15%.
That comes out looking an awful lot like it's a little bit high, but isn't it really close to 50%? Isn't that badass, Ange?
That's amazing.
Isn't that? Well, thank you for saying that, because that's when I look at repeated trials and statistics, I feel the same way. I look at them and I'm like, holy crap. Even though we have these crazy weeks where she gets really lucky and these other weeks where she's not so lucky, it balances out to right around what it should be. Now, it's not magic. What makes it not completely amazing is the fact that I have coded. If you look at the coding up here, I've made it be 50% by setting, that's this command right here. You don't have to know this right now, but that command right there makes it be 50%. And then if you uncheck this box, it makes it be 10% over here. But the thing about it is, when you do these kinds of statistical studies in the world, there is a coin flipping in the background. You just don't get to see it. So the only way to know what it's showing you is to start flipping and watch and see what the results are. You don't know. When you first encounter a coin in the world, when you were tiny, you probably didn't know that the heads and the tails both showed up at the same rate until you start goofing around with it. Then you're like, oh, okay, two sides, same shape. It makes sense that they'd be equally likely. But then you talk about anything else that has two outcomes, like R2-D2 and his feet. And you might say at first, well, I bet you he lands up on his feet more often than he lands down on his side. And then you start flipping. And you begin to realize that that's not what appears to be true. Cole?
Thank you.
You're
Yeah,
more than welcome. Thank you. That was fabulous to do. And if anybody wants that video about how to do COUNTIF, I'm more than happy to send it to you. I can make a copy of the spreadsheet, insert the command, do a little 3-minute video. It's a really handy function in spreadsheets to know. And it broke my heart, if I may pontificate a little bit. They removed the CIS 120 requirement from the general transfer degree at COCC years ago. It was a statewide removal, and it really broke my heart because now a lot of students can go through here and never take spreadsheets, never have spreadsheets ever. And that was one of the main reasons I wanted to put spreadsheets into classes in the first place, was this might be the only time you ever learn how to use them. So let's make it valuable for you. Hell yeah. All right, give me some more questions if you got them. I love these questions. Angie, can't thank you enough for that.
Thank you.
Now that we're there, for question 3, are you looking for another format, or I might be overthinking this, but another way to create something that shows the 50-50 chance, or are you
Very
just
good question,
wanting me to
Gabriella.
like keep track of, like, I'll just, I don't know. I don't know.
I got you, girl. I got you.
Yeah.
I got you. I love your question. This is a great question. Fantastic question. So if you look at number 1, what did you put for number 1? Generally, what fraction of the times Emily take out the trash? What did you put?
I wrote 50-50.
50-50, right? It's about every other time on average. And then how about Yasher?
Same.
The same as 50-50.
Mm-hmm.
Without having to use a Google sheet, if they literally were using a US quarter, how could you have gotten these numbers without the Google sheet? Think about using a quarter. Why would you use a quarter to make the decision?
Because it has 2 sides. It has that 50-50 chance.
There you go. That's all I'm looking
Okay.
for. Yeah, I think you had the answer, and then you're like, I need to write more because this seems too easy.
Thanks.
That will happen in this class sometimes. You'll be like, I think I need to write a couple paragraphs because this can't be right. Here's the news. I'm gonna share something with the 6 of you that are here with me right now. You are not, most likely, you are not going to learn any new math in this class. The math you already know in this class, the math you already knew before this class, we're going to push it into new places. So it's not the math that's going to be new here. It's the applications of the math that's going to be new here. And that's going to feel weird because a lot of people come into a math class, they're just like, teach me how to foil and go. And I'm like, no foiling. Very little algebra, actually. Very little algebra. Teeny tiny little bit. We're going to take division and we're going to think about division in a very, very important way. Riding my bike home from work yesterday, listening to the news, talking about coronavirus cases worldwide, blew my mind. A reporter made the mistake and said that the US has the worst coronavirus infection rate because we have the most number of infections. Made no mention of the fact that the US population is 320 million people. No mention of that whatsoever. Made a simple math mistake where they should have divided and they didn't. These are the kind of mistakes I wanted to, and good, Seth, I see you nodding, that's good, like, okay, and Angie was already nodding along with me. These are the kind of things that you're gonna look at in this class is like, when should you use division versus just counting? When should you use a percent versus not using a percent? It's really just applying the math. You learned all the math you needed in like 1st through 8th grade, honestly. This is, let's use that math to do something better. Let's use it more effectively. With your permission, of course.
So we're using this math for a more day-to-day context? That's
Yes, mwah, Seth, yes. It's funny, we were trying to figure out what to call this course years. I mean, we started working on this course about, I'd say 3 years ago. That's when I picked up the course from the guy that retired, and I realized that the course he had built just didn't make sense. I had to start from scratch. So everything you're working on this course is something that we like lovingly handcrafted. It's kind of like a small, like Bob's Red Mill flour. I feel like that with this. I've created this little tiny, when you go to the store and see a rack of Bob's Red Mill flour, you go to the store and see a rack of Sean's Topics in Math 98, lovingly handcrafted for you in beautiful Bend, Oregon. And we agonized over what to call it. And we wanted to call it citizen math. That was one of the first titles that came up. Citizen math. Everyday math actually came up. But we're like, God, if we call it everyday math, people aren't going to take it seriously. And I was like, that's part of the problem is we have to have this thing have like a name that inspires like awe. So that's when math literacy popped in. I'm like, ooh, I kind of like that, math literacy. And then the next one that you'll take, Math 105, is math in society. So yeah, dude, to answer your question, hell yeah. We want to make math that you can turn right around and use in your world. And that's what makes the courses, I think, appealing to a lot of people is I'm starting to design the Math 105 exam for them for week 5. Did you all know they're going to be piping the canals in Central Oregon over the next 10 years or so? All the canals in Central Oregon are going to get enclosed in large pipes. All right, so you're not going to see the canals with water running through them anymore as you go through town. That's a brilliant idea for many, many reasons. We're actually teaching Math 105 students how to measure their water savings in doing that, based on one figure given to me by the COID. The math they're using, multiplication and division. But when they get the final result, Ange, I'm looking at you right now. When they get the final result, they sit back and they go, oh my God, that much water? Yes, that much water. Maybe we'll use that problem when you're a 105. Maybe I might reuse that one. We'll see. But yes, Seth, long answer to your question. Hell yes. What else you got, friends? What else you got? I love these questions. They're so good. Oh, I just lost somebody. It's so weird. When somebody comes and leaves, everybody moves. It's like some weird arcade game.
So I do have a question
Please,
about
Angie,
the
please.
R2D2, the
Yes.
dot.
The dot
What are
plot.
these? Yeah, the dot plots.
Yeah, let's go look at it.
So the green versus the orange.
Oh, the dot plot's at the end, down here. Yeah.
Yeah,
Oh, yeah,
those
yeah, yeah,
ones.
Yeah.
So how
So
many
are you struggling
am I
with 16
counting
and-
each?
These questions here?
Yes. Yes,
Love
I
it.
am.
Go ahead. I'm going to stop interrupting you now, Ange. Go ahead.
No, it's fine. I'm just really, and like I said, well, first of all, math has been a challenge in this class, but I am having trouble determining, are each of these dots representing one time that a person flipped 20 times? Does that make
Exactly
sense?
correct,
The question
Angie.
that I'm
Exactly
asking.
correct. No, that's a perfect question. That's
Okay.
exactly what it is. So just like the dot up top was, each one, so this dot right here, the dot I'm drawing a little square around right there,
Mm-hmm.
that was a student in one of my Math 20 classes that slapped the R2D2 dome 20 times. That student ended up getting 8 standing R2s out of his 20, or her 20. This student here, they did it 20 times, and they ended up getting 11 standing R2s. This student over here, they got none. Is that cool? Oh, I think Angie's camera is starting to freeze. Oh, you're there. Okay, good. That does make sense. Good, good. Yep, each one. So I got a lot of data there, tons. I've kept track. This class is relatively new. It's only been kind of running for the past 2.5 years. So I've kept every data point that I had. I've been running the R2D2 experiment since the beginning, and I'm stoked to see it grow from term to term to term to term and keep adding to that graph, because that's really what good statistics is keep getting good data and putting it together and see what happens at the end. I wish I could do it with y'all right now, but we can't. So it's all good. It's all good. That makes sense though, Ange?
It does, yes. Thank you.
You got it. Now knowing that, I bet you can take it further. But if you can't, you can always ask questions. That's why we're here.
That's right.
What do you got, friends?
This assignment, I'm
Oh,
sorry,
go
this
ahead, Ange,
assignment
go
is
ahead.
due on Friday, correct?
Yes, ma'am. And if I may be more global, I'm going to keep that going with your permission. I'm going to say, like today's Wednesday, you're asking all these amazing questions about these assignments, and you're going to submit them before 8 a.m. Friday. And then Friday, we'll have another drop-in meeting just like this. You bring questions on the Turtle Lab and the Turtle homework, and we do the exact same thing, and then that's due before 8 a.m. on Monday. All term long, same thing. We just have these little drop-ins. If there's ever a day when you don't have questions, you don't have to come if you don't want to. You can totally bail out. You don't have to come every single day. This is the part that got screwed up in the scheduling. It wasn't expressed well in Bobcat Web scheduling that, you know, these are, I guess technically what I do is more like an online class than a hybrid class, except for the fact that we have these 6 hours of drop-in time. In an online class, you wouldn't have that. You'd be completely separate from your instructor. So that's the difference. So make sense, Ange? Make sense, everybody?
Yeah.
Cool. I had one 105 student, when she sat back in her chair yesterday, she's like, I like this already. It's like she didn't know how class worked, and we explained it. She's like, why didn't they just say that? Great question, my friend. Can I quote you on that? So we're working on it. Hopefully we'll be back in class next term and I'll see your beautiful faces sitting in front of me. I really hope so, because I want to have you in front of me in 105, but maybe if we're back here, we'll have it more clearly delineated. I hope we're not, though. I hope I'm not looking at Angie Skis and Seth's Yeti Blue Mic. I'm hoping I'm looking at your beautiful faces in front of me in class.
That would be nice.
Very nice. Very, very nice. I know we can do a lot of this remotely, but it's much better, I think, real time. I mean, think about right now. We're answering questions in real time.
Mm-hmm.
It's much more effective. Gab, do you have a question, Gabriella?
Yeah.
Please ask me that question.
So maybe we looked at this and I wasn't awake. So
That's
number 8
Let's look at it.
For the R2D2.
This one right here?
Yeah.
All right. Okay, let me just refamiliarize myself with the rest of the question, if that's okay, guys. So Sean Rule, that's me. It's funny, my friend Jessica went through this summer and took all my labs that I built and made them more usable for more than just me. So this lab originally was just like my son Max and our son Max and my wife Jen, and she's like, people don't need to know about all that. So loves to play this game. After playing the game for years, Max asked one night, I wonder how often R2 lands on his feet. Good. How do you think our experiment? Now, our experiment is to try to answer the question, Gabby, how often does R2 land on his feet? Okay. How do you think our experiment will be similar to the rigged coin version of Emily and Yasher? Now, if I may, Gabriella, I keep calling you Gabby and I apologize. I knew a Gabriella years ago and she went by Gabby. I'm gonna call you Gabriella unless you tell me to call you something like Gabriella. If I may, I'm going to go back to that Google sheet that we started creating with Angie's question, with your permission.
Mm-hmm.
Okay, so I'm going to reshare my screen. And I'm going to find that Google sheet. Here it is. And what I'm going to do, I'm going to erase all this data that we constructed there, okay? There's still going to be 52 weeks, so I'm going to leave that as 52 here. But now I'm going to uncheck the box so that it's the rigged coin now, if that's okay. All right, so right now, this is actually easier to count, but I'm still going to let Sheets count it. So it's going to say there's 5 out of 52 right now. How about now? Now there's 6. Now there's 2. Oh, Emily got lucky that year. Now there's 7. Now there's 3. Now there's 5. Now there's 7. Now there's 5. Now there's 6. Okay. So this year, 52 weeks, she took the trash out 5 times. This year, 6 times. This year, twice. You see how it's all over the board, Gabby? Gabriella, I got to work on that. I'm sorry. Gabriella, it's all over the board. But do you remember what we did last time, Gabriella? We added all these up, and it looks like there's 46, yeah? So there's 46 total times that Emily took the trash out. Whoops, why can't you see that? Did I not type it? Oh, hang on. There we go, 46. And then this is still 468 weeks. So what fraction of the time did Emily have to take the trash out? Well, let's figure it out. Say that again, Gabriella.
Divide 46 and 468.
Yes, and what is that about equal to?
1/10.
Yeah, it rounds even to 10%. It's not exactly right. It's not exactly 10. It's a little bit low because she got lucky that one year right there. But it's really close to 10%, isn't it?
Mm-hmm.
But Gabriella, if I may ask you, could you look simply at this outcome right here and know that it was 10%?
Yeah.
Or, oh, you could?
Well, close, that it's close to 10%.
Close. But would it be better?
Green ones.
Go ahead.
Just because of the green ones, every time you switch it, it's kind of close to that number.
I love your answer. If I may, What about the years like this where it's below? Oh God, what the hell just happened? Oh my God!
Emily's gone.
Whoa!
Emily quit.
Whoa!
I don't know, but by like week 10 of me having to throw the garbage, I changed the coin.
I'm sorry. You changed the coin. So I guess I wasn't expecting a 0. I haven't seen one of these yet, although I should have. But 10% is so close to 0. I know. Thank you, Angie. You're smacking me to wake me up. Thank you. I appreciate that. Wake up, Rule. Wake up. Come on. My point, Gabriella, is if you looked at just this result, could you tell it was 10%?
No.
No. You need to look at a bunch of results.
Yeah.
To kind of see it. That's what I'm fishing for in the lab itself. The reason R2D2 is like the rigged coin is because you can't just look at the game and say, it's gonna be 33%. What do you have to do to establish that 33%?
I have to test it.
You have to test it. But when we were just flipping a fair quarter, you didn't have to test that. The reason we use a fair quarter is because you know the quarter's fair. You know it's going to be half and half, 50-50.
Mm-hmm.
But that's only because you know it's a fair quarter. You know nothing about R2D2, just like you knew nothing about whatever coin Yasher and Emily were using.
Okay.
Does that kind of make sense, my friend?
Yeah.
Boom!
I need to test it to see what the percentage,
Exactly.
kind of like the theory of what it would be.
It's exactly right. Anything that happens with the percentage of time in the world, the way you establish the percent that it happens is by looking at lots and lots and lots and lots of trials of it and seeing what happens. I mean, for example, let me just, this is not part of the class, but I'm going to pull it up if it's okay with y'all. If you go to, let's see, I got to find it real quick. Close that, minimize this, ARA. That's something for you for week 4. Let's just go over here. I'll find it online. All right, so let's pull this over. I'm going to go to Math 105 for just a second and pull up a resource. Probability, flip a coin, roll a die. Okay, so we're going to roll a die in Excel. Let's see if it works. Actually, it might not work. Let me close all this other stuff down. Close, don't save. Okay, now we're good. Roll a die. All right. All right, so if you roll a 6-sided die, what is the chance that you're going to get any one of the numbers? So let me pull a 6-sided die right here. Here's a 6-sided die. What's the chance if you roll this die, you're going to get a 2?
1 out of 6.
1 out of 6.
I love it. 1 out of 6. Now, how do you know that?
There's 6 sides.
6 sides. I love that. That's one of the 2 answers I'm fishing for. Gabriella has the first one. There are 6 sides and...
Only one side can show at one time.
Okay, good. And only one side is a 2. Good. What are we assuming about the 6 sides by saying 1/6? Think back to your last homework and your last lab.
At some point, each of those numbers will show up.
With the same...
Likability?
Say it!
Likability?
With the same... Oh, I like likability. I mean, that.
Yeah.
Likelihood, but likability is
Likelihood.
really good, Seth.
Yeah.
I like likability. It makes me happy. That makes me happier than likelihood. Hey,
Probability.
likability is good. I like that. That's good. So, in other words, when you say 1/6, another way of saying that, Gabriella, if I may, is that 2 happens at the same rate as 4, and 4 happens at the same rate as 5 and 6. Well, that's 6 actually, but you get what I'm saying.
Yeah.
Have you all ever heard of cooked dice? You ever heard the phrase cooked dice? Have you ever been to a Vegas casino where they swap the dice out at the craps table?
Mm-hmm.
Why do they do that?
So that there's no loaded die.
What do you mean by loaded die, Seth?
What I mean is, people use certain mechanisms to make sure that one die hits on every single time, or more likely than not, that 2 or the 1 or whatever.
Seth just said something very important. The reason I called it cooked dice years ago, what they would do is they would take a pair of dice like this and they would put them in the oven with 7 facing up like this. and they'd raise the temperature of the oven just enough to make the plastic melt down a little tiny bit to make the bottoms heavier. What that did was it gave them a slight advantage so that that 1 and 6 would show up a little bit more than any other combination. And that slight advantage was enough to win at craps more than you should, which meant you'd actually make money. Now, this cannot happen anymore because you can't go into Vegas and like, hey, dealer, I got my own dice. Can we use these? Doesn't exactly work like that in legitimate casinos. Maybe in like National Lampoon's Vegas Vacation, but not in like legitimate casinos. So the idea is a fair die looks kind of like this. Gabrielle, if you may, here's me flipping a fair die over and over and over again. Do you see those 6 pie chart slices?
Mm-hmm.
Do you see how right now there are quote unquote too many 2s? There's too many 2s right now and not enough 3s. But if I keep rolling the die, do you see what's happening with the pie chart slices?
They keep shifting just a little bit.
They do. And right now we still have too many 2s. But if you look at the percentage of 2s up here, that percentage of 2s is coming down over a long period of time. It dropped to 20. It was up at 23. Now it's down to 19. And they're beginning to shift towards all of them happening at the same rate. Now it's down to 18. You see what's going on? Now, we could have known this was going to happen if we knew the die was fair in the beginning. But the catch is, when you do a statistical study, you don't know what the percentage is in the beginning that you're studying. What is the rate of ADHD in East Coast males born in Delaware between the years of 1970 and 1975? 100%. Here's one right here with ADD. It's 100%. It's ridiculous. It's ridiculous, right? You'd have to go out and get a large number of East Coast males born between 70 and 75 and test them properly, however you test for ADD. Just compare them to me, I guess. And then you'd have a percentage based on replicated data. Gabrielle, does that make sense?
Yeah.
That was definitely an over answer to your question, but I think it deserved an over answer, honestly. It's a great, great question. I think it gets to the heart of this class, which is, let's look at a bunch of data and see what happens. What else we got, people?
Oh, nothing.
I'm out of coffee. This sucks.
I'm going to ask a question.
Angie's like, no, you're good. Drink some more water.
Just thinking I'll need to bring my own coffee next time to keep up.
I tell you, it's funny. I go back and watch the videos just to check in and make sure that I'm not like, blah, 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 blah. And I don't talk to you all like I talk to my friends, which is warp speed, which I know some of you were like, good God, if this isn't warp speed. And it's amazing. I can't believe that I can actually dial my East Coast Italianness back enough to get ideas across so that you understand them. The first year I worked here, like 15, 16, 17 years ago, all my student evaluations were like, dude, somebody get this guy off of cocaine. They're just like, we can't keep up with him. We cannot keep up. Gabriella, go ahead.
Sorry, and I haven't finished the...
It's okay. Go ahead. Ask your question.
But on 16, right before it says, please turn to the next page to answer a couple of questions about them. Is there a page missing?
Hang on 1 second. Let's go look. Let me go find that. I closed it, so I have to open it again. Give me a sec. We're in the lab, right?
Yeah, lab 2.
Beautiful. She's opening over here. 16. So let's see. I'm going to find that. You said, please turn, please. Where is it?
Right above 16.
Oh! That's okay. That is from me not converting the file right. No, these would have been on the next page. No, you're good. These are the next questions.
Okay.
That's it right there. I need to just delete that sentence out of there.
Okay.
Thank you for catching that. I didn't catch that when I was formatting. I'm going to change it right now with your permission, if that's okay.
Yeah.
Yeah, I'm going to change that. That's the R2D2 lab, and we're going to take that line out because we don't need it, obviously, because you're on that page. Boop, boop. Let's delete that. There we go. Delete, save, re-upload. Thank you for catching that, Gabriella. Much appreciated. Let's change to a PDF. Boom. Yes. And I will upload that. So now when you reload it, it will actually look like the correct thing. All right. What other questions we got, you badasses? This is fun. I'm enjoying this. Your questions are exactly the ones I expected, along with some bonuses that I was not. That makes me even happier.
Okay. I have to head to a exciting budget meeting, but
Oh, Gabrielle, I remember you saying that in your email yesterday. Oh,
so
I'm
I
sorry.
have to head out. But if I have questions that come up later, can I
Email me. I got office hours at 3:30. We can also
that's
do a
right.
quick little Zoom meeting. I got a class from 1 to 3. I got a Zoom meeting at 10:30, and I'll be grading your stuff somewhere. And just send me an email if you got questions. We'll figure it out, okay?
Okay, thank you.
You got it, my
Bye.
friend. Have a good meeting.
Thank you.
All right. Let's make sure I did that right. Did I upload?
I'm gonna head out too, Sean.
Okay, Ange. Have a great
Thank
rest
you
of your
so
day.
much.
You
Have a
are
good
more than
day,
welcome.
everybody.
You too.
Bye.
Let me just make sure I reloaded that correctly. Gentlemen, what do you got?
I don't have any more questions.
Okay, Seth.
So I'm pretty much good. But as you said, if I have any more, I'll send you an email.
You are 100% correct, Seth. And I, again, am sorry that this was unclear in the beginning. I appreciate your email that you sent. There we go. It's fixed. I appreciate that email. I'm glad we got it squared away. And I'm glad you stuck with it. I'm really glad we didn't lose you. I think we're going to enjoy this class together.
Yeah, no, I'm glad to be in the class. I didn't want to drop it, so I'm glad you didn't drop me. So I'm very appreciative of that.
Oh, you are more than welcome. I promised myself, I'm not dropping anybody. They can drop themselves if they want to. I'm not dropping anybody this term. I'm going to stick. I mean, I understand the weirdness of this term. I mean, it's just like it was in the spring, but even worse. Because is this your first class at COCC or one of your first classes here?
No.
Okay, you've been here
I'm a second year. Yeah, I'm a second year student.
So you survived spring term. You were here for that.
Yeah. But this is my first math class at COCC, so
which probably can feel a little bit intimidating. Math remotely, right?
Right. And I already sent you an email, but I have a hearing disability.
You did?
Yes. And so math is a little bit tougher because of that. So
how are the videos working out? The videos that are linked in, are they okay?
Yeah, they're loud and clear, so I can hear them. So if I ever do have any questions to be math related, I think and there might be some if it gets really to the point where I'm struggling a little bit, I might have to see if you and I one-on-one do a Zoom meeting and go over it together.
We will do that. We will do, and we're going to talk to Jamie if we need to figure out what other resources are available. Never, and it sounds like you're not going to do this, but never leave me in the dark. Always let me know what's going on, and we'll figure it out, Seth. Promise.
Okay. Excellent.
Awesome.
So I'm going to let you go, but thank you so much for your help, sir.
You are more than welcome, sir. We'll talk to you soon, Seth.
All right. Thanks.
You got it. Nathan.
Yes, sir.
How you doing over there?
I'm doing all right. Hey, I actually do have a couple more questions for you.
Perfect. Oh, and always jump in when there's that little lull. Just jump in, but let's do them.
Sure. Yeah, I try to figure out the best time to jump in, and sometimes it always feels like I always want to wait till the end.
I'll tell you what. I was going to tell you, if you ever figure out what the best time is, will you tell me?
Okay.
Because I sure don't know when the hell it is yet.
Fair.
Let's hear it, my friend.
The first question is kind of a joke question, but it kind of might answer something. But it's gonna be for number 6.
Numbers on the lab as well?
Yeah, on the labs. Yeah.
All right, let's take a peek. Number 6. Number 6 is okay. I'm pretty sure I know how you answered that last one. Okay, so let's look at the last one.
What do you think my answer was for number 5?
For number 3, excuse me, from that last one. What makes it different from number 3? Now, I got to look at how I phrased all this. Let me look again, Seth.
Sure.
Or excuse me, Nathan. What makes it different than number 3? Number 3 was the one. Okay, number 3 was the one Gabriella asked about, which was you're using a U.S. quarter. Okay. Number 5. Suppose Emily decides to pull a fast one on Yasher and rigs a coin so it flips more often in her favor. Answer the following questions without using the Google Sheet. Got it. Suppose that Emily and Yasher are using Emily's rigged coin to flip to make their weekly decision. What fraction of the time will Emily take out the trash? Hint, we know it's going to be less than half. She rigged a coin in her favor, but what fraction would it equal approximately? Either answer or explain why you can't. I think I know what you said.
Go for it.
You said you couldn't.
I did give an answer actually.
You did. How dare you? What did you say?
I said 1/4
Why?
because I just took 1/2 and then just if she rigged a 50-50 chance in her favor, if she's rigging it, then I would say she just doubles down and makes it 1/4.
But why? What if she tripled down and made it a 6th?
I think that would be too obvious, and Yash would figure out the problem.
Okay, so Nathan, what you're doing, sir, is you're over answering. You're playing the strategy game. You're saying, okay, if I'm Emily, I want the coin to be rigged slightly so that I take the trash out less, but Yasher doesn't notice that I'm taking it out less. That's what you're answering, I think.
Yes.
And I love that answer. Leave it. Don't change it. That's not what I was looking for. I was looking after, there's no way you can know without knowing how the coin is put together.
Yeah, and
Like
in my
what you
answer,
did was you created a coin for yourself, which I love, by the way. It's 3-to-1 instead of 1-to-1. I love that. That's great. She could be even more subtle and make it 2-to-1, make it flip 1/3 of the time.
Okay.
I mean, that would still be better for her, but then it would be even less obvious than 1/4 of the time.
Yeah.
Leave your answer. It's gorgeous.
Okay.
But do you see how when I threw it back to number 3, how it is definitely a harder question because without knowing how the coin is put together, you don't know what it's going to be.
Exactly. I didn't know how she I don't know how she rigged the coin. So,
Exactly.
yeah.
And that's the whole point. You don't know how it's rigged, so you can't approximate the probability without seeing how it behaves.
And without multiple tests. Yes.
Exactly, sir. You got it, friend. Well done.
All right, and I have one last question.
Let's hear it, dude. This is great.
It's for number 18.
18.
The last question.
Last question. I forget what the last question was. I got to go look at it.
Fantastic.
So 16 was the bounce method. 17 was the no bounce method is not. Sometime blah, blah, blah. Okay, good. That was that. You may have also noticed that Sean's results from the standard method aren't quite in line with the historical student results. So that what I mean is with that was, this was what we just did in the videos that you watched.
Your plot versus the
right. So this was that new little plot that I made in the YouTube videos.
Yes, which I enjoyed, by the way. Fantastic.
Oh, with the pennies in the shed.
Yeah, I loved it. It totally made sense. The sharing and the averaging.
Oh, good. Oh, you mean it made sense? Like the content made sense. I thought you thought it was kind of funny that I was out there in my hantavirus-infested shed with pennies on the ground. You meant the actual content.
When things actually move in a video, I kind of understand. I'm a visual learner, so that definitely helps.
Oh my goodness, Nathan, this is so good to hear, my friend. Oh, this makes me so happy because I have to stop for just a second if it's okay with you.
Sure.
When I sit down to make a video for your classes, I agonize over what to put in it. I want to put enough in it to be helpful, but not so much that it puts you to sleep.
Yeah.
And I want it to be dynamic. I was just making you a video yesterday for something you'll see in week 4, where I'm talking about the relative height of 2 graphs. And I'm like, do you see how this graph is 1/3 as big as this graph? And then to drive that point home, I have little tiny things, little rulers show up. 1, 2, 3. So hearing you say that just reinforces the fact that I should keep doing that.
Yes, it works.
Thank you, sir. Very good. Thank you very much. I want to pause and say that.
The millennial X generation, so like we like visual graphics.
Dude, and as someone who was taught by boomers who didn't use the visuals as much as they could, not for any of their fault, that's how they weren't trained to do that.
Sure.
But as a Gen Xer, growing up and realizing I need better tools to understand this, that's when I developed them. So good to hear. I love it, Nathan. Thank you. All right. So now we're back here. We're looking at Sean's. I noticed that Sean's results aren't quite in line with the historical student results. Okay, so let's look at Sean's results again. So I'm going to take a little screen grab of this. And were you on the call? I think you were, Nathan, when I overlaid the curve on the historical student results, right? So I'm going to do it again here. Where does the hump appear to be here?
Between 4, 5, and then down past 7.
I agree, sir. I think it's going to look something like this, maybe, yeah? Mm-hmm. I mean, it's definitely like a wider curve, but the hump is definitely like here. Yeah?
Yes. 5.
Yeah, 5. I like your answer. Between 4 and 5 and 6 and down, it's heading down towards 7. So even like between 4 and 5, but definitely if you compare that to where the, oh goodness, not that. No, that was the video. I just accidentally clicked on it. Sorry. Hang on a second. Gotta go back to the lab now. If you look at the historical results, remember where the hump was here?
Yeah, it was more on 2.
Yeah. So I guess my question is, what could explain why did I get so many higher results than historically?
Well, I see that there's more dots on the students' tests, and so the more dots there are, that's more tests that they applied.
Which means whose data are you going to put more stock in, mine or theirs?
The students, because over multiple tests, it gives you a better average.
You have to, right? You got to go with more data, assuming all the data is good, which there's no reason to think it's not. I watch these kids. We develop the rules about pops and bounces and everything. Assuming the data is good, you got to go with more data. 100% correct. So that is what I was fishing for. Like Sean only did it, what, 18 times, I think is all I did?
Yes.
Right. The students have like 100 or more than 100 times. So go with theirs because theirs is going to be more indicative of what's going on.
Okay. Yeah. It's just good to hear. I guess I'm just asking rather than not knowing, asking for validation.
Totally. And that's one of the reasons I love these little drop-ins, so we can get that validation.
Yes. And on the point of the graphics and the video, that's working well. And for me personally, these Zoom meeting drop-ins are working fantastically.
Nathan, thank you for that. I was actually close to a breakdown on Tuesday because so many students were emailing me. I don't know what's going on. I don't know what's going on. And I had to actually sit back and realize, I'm like, okay, you're not hearing from the ones that it's working for.
Yeah.
Right? Like I'm hearing from students that are having a hard time getting logged in. They're having a hard time getting access. They're having a hard time paying tuition. I'm not hearing from Nathan, who's saying like, this is working great. So I had to remind myself, be a statistician, Sean. You're getting a lot of outlier results where students are having a hard time.
Hey, just it ties in right here with the lesson.
And it's funny because my emotions started, because I'm an East Coast Italian, I want everybody to be successful and have everything they need. I want to hug everybody. But I had to remind myself that you're only hearing, Sean, as you just said, Nathan, I'm hearing from these folks.
You're the loudest.
I'm not hearing from these folks. So I had to remind myself of that. And to hear you say that makes me feel like, okay, Nathan is actually down here in the group that it's working for. And there are very few that it's not working for. And if I work really hard, I can get them over here eventually. So that's my job.
Well, I appreciate it. It's working for me. So
Awesome, Nathan. I think it's working for a lot of people. So it's good to hear, my friend. And I'll be right here. I'm going to keep this open until 10. And if you have any more questions, just email them over. We'll get it figured out.
Okay. I'll see you on Friday.
Yes, you will, sir. Be well.